So for this section 3.1 graphing relationship, this one's going to have a lot of describing graphs and not a lot of computation. So it's a lot of you analyzing visuals and interpreting them. Okay, so for continuous graphs, it's a graph that's made up of connected lines or curves. Other types of graphs are not continuous. So anything that has a hole or a gap is not going to be continuous. A discrete graph then is made up of distinct unconnected points, such as these right here. That would be a discrete graph. A continuous graph could be curves, straight lines, curves, straight lines. That's a continuous graph. Something that you really need to pay attention to is keywords that you can use to describe, or that in the word prompt it uses to describe what's going on. So like a horizontal line is a line going from left to right, and you could use words such as stays the same, does not change, remains constant, does not move. Anything that is horizontal, think of it, it has not moved position. It is just straight across. Slanted upward would be something that looks like this, and with a dip, it could be have a greater slope or steepness than this one. So increases, goes up, climbs. That is a slanted upward. So this is a movement and is a consistent movement up. Slanting going downward is basically it starts on the top left and goes to the bottom right. Keywords are decreases, goes down, and descends. And the steepness depends. It could be more steep or less steep depending on what the slope is, and we'll deal with that in future lessons. But the steeper it is, the faster it rises, or the faster it's going down. So on this slide, this is the answers that we came up with, or that I came up after our little discussion. Remember, the question said that the distance a delivery run is from the warehouse varies throughout the day. The graph shows the distance from the warehouse from a day from 8 a.m. to 5 p.m. So at this point right here, this is where the warehouse is at 5 p.m. and this is where 8 a.m. sorry. And this is where he comes back to the warehouse at 5 p.m. So we have at this point at 8 a.m. he leaves the warehouse. And at this point over here at 5 p.m. he returns to the warehouse. Anything in between it, he's going away from the warehouse, going away to slower space, probably stopping, going away, stopping, going away, stopping, coming back after 5. He's returning back to the warehouse. This is the information we were talking about in class. So now we have information that we could fill in for A, B, and C. For segment 1 right here, that the delivery man moved away from the warehouse. So he's moving away from the warehouse. And if you notice, this has a steeper slope, so it's rising faster. So he's probably leaving the warehouse a little faster. This has a less steeper slope, so that means he's going a little slower. So this is why I wrote the segment 2 shows that the truck moves away from the warehouse at a slower speed than segment 1. For part B, it says based on the time frame, what changes in the distance from the warehouse is represented by segment 6. So this segment 6, remember, right here he's going away from the warehouse. Right after 5, he turns around, and now he's coming back to the warehouse. So this is what I wrote. The segment shows that the truck begins to return to the warehouse during segment 6. On C, it says which line segments show its intervals where the distance did not change. And remember, does not change means it's a horizontal line. So this is a horizontal line at 3, a horizontal line at 5, a horizontal line at 7. So these are where it doesn't change. And then we're using the question and answers from part C to answer our D. And that one says, what is a possible explanation for these segments? Well, for the segments that they're horizontal, he's a delivery man, so it makes sense that he's probably delivering packages I think one of you mentioned that maybe he is stopping at a stoplight or a stop sign, but this is where he's not moving. So the van is constantly still. So this is why came with this hypothesis. For this one, we had three hoses that were filling a water barrel. We had a green hose, which was filling a water barrel at a constant rate. And after looking at our graphs during class, we all agreed that a constant rate is rising consistently up. So anytime you hear the word or see the word constant rate, you're going to think of a linear graph, either rising or falling. In this case, since we're filling a barrel up with water, it's consistently rising up. And then for the black hose, it says slowly open when filling the barrel. That means water is going in slowly. So we all agreed that it was going to be A. So it's slowly filling on the barrel. And at a certain point, it started getting filled faster and faster and faster and faster. So we agreed that this would be the black hose. This would be the green hose. That means that C would be the blue hose because it is they open the water completely open. That means a lot of water is flowing in, and then it slowly is being closed. So this is why it's rising fast and then it slows down. That information helped us fill out information for A and B. A says which graph best represents the amount of water in the barrel filled by the green hose. Since it said it was consistently rising at a rate, we said since the flow of the water is constant, the amount of water in the barrel should be steady increase. This is a steady increase. Thus, graph B best represents that situation. Then we had for part B, we had to describe which would be better for A and C. We stated that the water level for graph A begins slowly and then increases rapidly over time. That means it would have to be for the black hose because the black hose will slowly open and then to fill the barrel. That means that for graph C, it was the blue hose, which means that the water level for the graph C increases rapidly, then slows down over the time, as you can see on the graph right here, which is going really fast, filling in with water, and then slows down right there.